What's up, you freaking geniuses? So in this video, I'm going to teach you how to graph parabolas in vertex form. And just to remind you, this is vertex form right here. So f of x is equal to a times x minus h in parentheses squared plus k, right? And a couple important things to point out here is a right here, it's just a number. If it's positive, that means your parabola is going to open up like that. And if it's negative, your parabola is going to open down like that, right? And the other thing you want to take away from here is the h and the k. So this tells you where the vertex is. Okay, so this is basically your x and your y. Now the only difference here is for the h, you would basically take the opposite sign. So since here we have a negative h, right, minus h, for your vertex, you would put a positive h. And for your k right here, you just keep whatever sign it has. So here it's positive, so it would just stay positive like that. Okay, so to clarify a little bit, let's go over this first example right here. F of x is equal to 3 times x minus 3 in parentheses squared plus 6, right? So the first thing you want to look at is your a number right here. So you can see it's positive, right? Positive 3. So that means our parabola is going to open up like that, okay? And then to find the vertex, again, we need to look at h and k. So remember, this is your x and this is your y, right? So here your h is negative 3, so for your vertex, it's going to be a positive 3. And then here we have a positive 6, so that stays positive 6. Okay, so the vertex for this parabola is at 3, 6. Okay, and also sometimes your function over here is not going to have a number at the very end like that. So basically you can take this as like saying plus 0, okay? So then in this case, the vertex would be at 3, 0, okay? And that's just when you don't have a number at the very end. But for this example, we obviously do, right? We have the 6, so we'll leave that 6 in there. Okay, so we know where the vertex is, but in order to graph a parabola, you need at least 3 points, right? So we can make a little xy table to plug in some of the holes. So we know 3, 6, right? Another point I normally like to plug in is 0, okay? And that's because whenever you plug in 0 to a function, it's normally easy to calculate, right? Okay, so then if we plug in a 0, this is going to be equal to 3 times 0 minus 3 squared plus 6, right? 0 minus 3, that's equal to negative 3, and then negative 3 squared is equal to 9, right? So then this is equal to 3 times 9 plus 6. So 3 times 9, that's equal to 27, so 27 plus 6 is equal to 33, okay? So then our y value right here is 33. Okay, so let's plot these 2 points first. And here's a graph. Okay, so this is going to be kind of a tall graph. So the first point we're going to plot is our vertex at 3, 6. So we're going to come here and go over 3 and then up 1, 2, 3, 4, 5, 6. Right, there's our vertex. Then the other point we're going to plot is 0, 33. So 0, 33 is right there. Okay, so this point right here is at, just to clarify, 3, 6. And this one is at 0, 33. Now, you might have noticed I didn't plug in a third point right here, and that's because you can basically just use your graph to find the other point. So to get from this point, from the vertex to this point, we have to go over 3 and then up 27 spots, right? Because this is 6 and this is 33, so we're going from 6 to 33, so that's 27 spots. So to find the other point on the parabola, we can basically just go in the opposite direction, right? We can go over 3 this way and then go up 27 spots because, well, a parabola is symmetrical, right? So we can go over 3 in this direction. So we can go over to, let's see, this is 3, so 4, 5, 6. So we're going to go over to 6 and then up to 33 right there. Okay, so this spot right here is 6, 33. Okay, so then you can just connect the dots like so. Okay, and the last things I want to point out are the axis of symmetry, domain, and range. So the axis of symmetry is just a vertical line that runs straight through your vertex. That's straight enough. So the axis of symmetry here is at x is equal to 3, okay? And then to find the domain and range, the domain is all your x value or x limits, and the range is all your vertical or your y value or limits, right? The domain is going to be the same for all your parabolas. It's always going to be all real numbers, and you can just write the little symbol like that if you want, okay? And then the range is just the vertical limits, right? So you can see the parabola, the lowest point right here of our parabola is at y is equal to 3, right? And then the parabola goes up in both directions towards positive infinity, okay? So for the range, you can say that all your y values, y, are greater than or equal to positive 3. Okay, so hopefully that wasn't too bad. Let's try one more. All right, so here we have p of x is equal to negative 1/3 times x plus 3 squared minus 2. All right, so here you can see we have a negative a number, so that means our parabola is going to open down. And then to find the vertex, again, we just need to look at h and k, right? So this is x and this is y. But remember, you want to take the opposite sign for your x, okay? So for the vertex, our x is going to be at negative 3. And then for our y, you just keep it the same, it's negative 2. Okay, so there's our vertex, but again, we need to find 2 more points, right? So again, we can make a little xy table, xy like that. So again, we know this point right here, it's at negative 3, negative 2, and then I'm going to pick 0 again because I like using 0 since it's normally easier to calculate, right? So if we plug in 0 to this function over here, the function is going to be equal to negative 1/3 times 0 plus 3 squared minus 2, right? 0 plus 3 is 3, and then 3 squared is equal to 9, right? So then this is going to be equal to, I'm going to move it down a little bit, negative 1/3 times 9 minus 2, right? Negative 1/3 times 9 is equal to negative 9/3, so then minus 2, right? 9/3, that's equal to 3, so then this is equal to negative 3 minus 2, and negative 3 minus 2 is equal to negative 5. All right, woo. So our y value for when we plug in 0 is negative 5. Okay, so again, we have 2 points, so we can at least start with that. So let's graph that here. Okay, so let's start by graphing the vertex at negative 3, negative 2. So negative 3, negative 2 is right there. And we'll label these negative 2 like that. And then 0, negative 5 is our other point, right? So 1, 2, 3, 4, 5. So this is 0, negative 5. Okay, and then again, to get from this point to this point, we have to go over 3 and then down 1, 2, 3. Okay, so to get to the other point on our parabola, we're going to have to go over 3. So we're at negative 3 right now, so we'll go over to negative 4, negative 5, negative 6 is right there. And then, so go over 3 and then down 3 right here, right? So this spot is negative 6, negative 5. Okay, and then just connect the dots like that, right? Again, the axis of symmetry just runs straight through the vertex. If I can draw a straight line, there we go. Look at the top part. So the axis of symmetry is equal to x is equal to negative 3, right? And then again, the domain and the range. So the domain's always going to be all real numbers. And then the range for this one, well, the top of our parabola is right here, right, at y is equal to negative 2. So the range goes from negative 2 down towards negative infinity, right? So we can say that the range is all the y values that are less than or equal to negative 2. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.